Hey guys, today we are going to continue talking about radians, which we started yesterday. Remember, today we're talking about reference angles and a little bit of word problems. So, how do I find reference angles of angles that are in radians instead of degrees? So if you remember what we talked about on Monday in class, whenever I'm looking for a reference angles are always positive and they're always coterminal with whatever angle you're talking about, but you're looking for this bow tie on your coordinate grid. So your reference angles will be over here, and they always make it with the x-axis. So it kind of makes that bow tie going on, and that's what we're going to be looking for. So let's start. We're going to do this in radians this time. Okay, this is just a reminder of what your unit circle is. Remember, your unit circle is like your trig BFF. If you can remember all of those angle measurements, and then we can convert back and forth, we can get a lot of stuff done. We're going to learn a little bit about special triangles using these degree measurements, but this might help us when we're looking for those reference angles. Okay, so again, we're looking for reference angles of angles in radians. So our goal today is to draw the terminal side of each angle and tell what the corresponding reference angle is. So the first one that we're going to deal with is 4 pi over 9. So there are a set of steps that you're going to use while you're solving these. The first one is, if your angle is not between 0 and 2 pi, we need to find a coterminal angle. So if we're looking for one that's maybe larger than 2 pi, negative or positively, we want to find that coterminal angle so that we can graph it effectively. So the first thing I notice about number 1, we are okay for step 1. Okay, so we are good. We are in between 0 and 2 pi. Something that was bigger than 2 pi would be bigger than 18 pi over 9, and we're good. So my second step then is to figure out what pi and 2 pi are with a common denominator. Because remember, we're going to use that on my coordinate grid in order to make my sketch. So pi with a common denominator, remember we have to use the same one, so pi over here would be over 9, and I have to multiply the top and the bottom by 9, so 9 pi over 9. Okay, 2 pi, we just kind of said it, but we need to have the denominator be 9. You have to times the top also, so we would have 18 pi over 9. Okay, so that kind of gives me an idea on my coordinate plane where this guy's going to fall. My next step is to ask yourself, would this angle be closer to pi or 2 pi, and then sketch the terminal side? So it's kind of what we did at the end of Monday, Tuesday's video for radians day 1. So when I look at this guy, he's definitely closer to regular pi. He's closer to 9 pi over 9 as opposed to 18 pi over 9. And you can always go ahead and remember this angle is also 0. So if you wanted to try to find this middle angle up here, that would be, the middle would be like 4.5 over 9 pi. And so that's definitely going to be over here in quadrant 1. Almost on the axis, but in quadrant 1. So this would be 4 pi over 9 sketched. Okay, now that I have my sketch, I have to find that reference angle. So you're going to ask yourself, how close is that angle to the x-axis? So remember, your reference angle always is positive with your x-axis. And so when I look in here, I say, well, to get to that point, I just needed to go up 4 pi over 9. So for your answer on this one, the reference angle for 4 pi over 9 is just 4 pi over 9. Okay, I know it seems silly, but we're going to go through these steps a couple times so that way we can figure out ones that are probably not as simple. Okay, so 4 steps, that's your reference angle. I believe there's not a step 5. Okay, good. So let's try this one more time. Well, a few more times, but we'll definitely try this with one that's maybe not as simple. So number 2, negative 5 pi over 8. So step 1, we got to make sure it's between 0 and 2 pi. Now, this one is not technically between 0 and 2 pi because it's negative. So you can always find that coterminal angle, or you can just jump backwards when you're drawing your grid. Okay? So again, it doesn't matter if you want to go on your negative side or if you would rather go and find that coterminal angle. So we're going to go and write pi and 2 pi with with a common denominator. I'm negativing today. Okay, so this is your 0 degree angle. Remember, if I'm going backwards, then this guy would be negative 8 pi over 8. And if I went all the way full circle, I would be negative 16 pi over 8. Okay, so now we're going to ask ourselves, is this angle closer to pi or 2 pi? Or is it closer to negative 8 pi over 8 or negative 16 pi over 8? Well, it's closer to negative 8 pi over 8. And then if you want to remember, you can always label this other angle, the 90-degree angle down here. So this would be 4 pi over 8. 5 pi over 8 is above that, so we're going to draw our angle right here. And remember, we went the negative direction. Okay, so now at this point, we're going to look for our reference angle. We want to know how close is this angle to the x-axis. So remember, you're always going to draw up or down to the x-axis. This is going to be your reference angle right here. And so when I'm looking here, I want to know how close is that to that x-axis or to that pi degrees. So what I can look at is I can always take pi and subtract whatever this is. So I'm just going to do it positively since we know that we're dealing with positive values for my reference angles. I'm struggling with my vocab today, guys. Sorry. So we know this is 8 pi over 8. Or the same thing as pi. I'm going to subtract that 5 pi over 8, this whole angle, to find that missing part, right? Because this is a whole 180. I would subtract the part that I don't care about. I want this part. So that would get me that my reference angle for this guy was 3 pi over 8. Okay, again, your reference angle is positive. It's always going to be with your x-axis. And so you can just subtract that 180 or possibly the 360. Okay. So that's if you have a negative. Let's now look at 19 pi over 6. Okay, so remember, your first thing to do is to see if your angle is in between 0 and 2 pi, and this guy is not good. Okay, if it was in between 0 and 2 pi, it would have to be 12 pi over 6, so less than 12 pi over 6. This guy's greater than 2 pi, so I'm going to go ahead and make it less than 2 pi, find that coterminal angle, by subtracting 2 pi from it, and 2 pi would be the same thing as 12 pi over 6. Okay, so that gets me that my coterminal angle is 7 pi over 6. So that's the guy I'm going to graph, and remember that I took a whole 360 or 2 pi to get around to that guy. Okay, so the next thing I'm going to do is find pi and 2 pi in the same common denominator. So remember, 0, this guy is positive, so he is going around the regular direction. So 2 pi would be 12 pi over 6. We just found that one. And 1 pi would be 6 pi over 6. Okay, and remember, you can always label your 90-degree angles too, and that would be 3 pi over 6 and 9 pi over 6 if you need to. Okay, so again, my coterminal angle is 7 pi over 6. So I look, it wouldn't be in quadrant 1. That's too small. 7 is not between 3 and 6. So 7 is between 6 and 9. So that means that this is where my angle is going to be. But remember, he came around a whole 2 pi before he got there. Okay, so now I've sketched my angle, and I'm going to ask myself, how close is this angle to the x-axis? So remember, you're always going to have your reference angle be with the x-axis, and it's going to be positive. So when I look here, I want to know how far away is that guy. Remember, this is the same thing as 7 pi over 6. So a couple things you could do here. You could say, well, I know I only went pi over 6 to get from 6 pi over 6 to 7 pi over 6. So this angle measurement right here is pi over 6. Okay. The other thing you could do is take that bigger value, the 7 pi over 6, and subtract that 180. And you would find that that is also pi over 6. So my reference angle is pi over 6. Okay, again, when you're bigger than 2 pi, you need to subtract, so that way you can find that coterminal angle, which is what we did right here. We sketch it, we figure out how close it is to the x-axis, and then we move on with our lives. Okay, we're going to do 23 pi over 13. Again, the first thing you ask, is this in between 0 and 2 pi? And funny story, 2 pi here is going to be 26 pi over 13, right? If we were looking for that. So this guy is actually okay. He looks like he's really big, but that's okay. we can still do this. Okay, and you could also figure out the coterminal if you were worried about how big that number is. Okay, so we can go ahead and we can say, well, I just said that 2 pi is 26 pi over 13. Again, just times the denominator by 2. Then that means that 1 pi is 13 pi over 13. And you can find that middle one if you would like. So when I look at this, I ask myself, is 23 closer to 13 or to 26? Closer to 26, so that means this guy is over here. And again, we went around this direction to figure out that angle. And then I'm going to go ahead and find that reference angle. So again, you're going to make it with the x-axis. This is your reference angle. And so if I'm looking for that leftover part, I know that this piece right here, let me get a different color, this piece right here, the whole thing is 180. So I'm going to take that 180, or the pi, which we just said was 13 pi over 13, and I can subtract the 23 pi over 13. Now that seems kind of silly, right? Because I'm down here. So if instead you want to do that missing, which we know that this was 3 pi away, you can. Or when you look right here, you could also take this and make this 26 because it's bigger. Okay, I probably could have just erased. Struggle. Okay, so 26 pi over 13, since it's closer to 26, makes more sense to use this way. And I'd find out that leftover section would be 3 pi over 13. So my reference angle positive with the x-axis is 3 pi over 13. Okay, last but not least, let's deal with a negative angle, or another negative angle, I guess. So when I look here, I want to see, is this between 0 and 2 pi? And 2 pi, if you want to just start out with that every time, would be 6 pi over 3. So this definitely is bigger than 2 pi. It's actually bigger than negative 2 pi, I guess. But when you're looking there, that means that I need to find a coterminal. So when I'm finding a coterminal, I'm just going to take my angle, add 2 pi to it, which we just said was 6 pi over 3, and that gets me negative 5 pi over 3. Okay, now you can continue until you get this into angle measure that you like, so you can add this to be 6 pi over 3 and get that your angle is actually pi over 3 as far as coterminal, or you could graph this negative 5 pi over 3. That's not incorrect. Okay, so if I want to graph this guy, pi over 3, again, label your axes. So this guy's 0, this guy's 3 pi over 3, this guy is 6 pi over 3. And since I had to plus or minus the 2 pi twice, I did it right here and I did it right here. That means that my angle is coterminal with pi over 3, which would be in the first quadrant, but I had to go around a few times to get there. So I went around once, twice, and then I got here. Okay. So now I look and I try to make that angle with your x-axis, and I ask how far away is that guy. And funny story, in order to get here, you just went up 1 pi over 3, or you could subtract it from 180 and figure that out, but your reference angle would be pi over 3. Okay, so that's the basics of finding reference angles using your radian measurements. Remember, when you're looking at your unit circle, you're always going to want one of these guys for the most part when you're finding reference angles for 3, 4, or 6. It's going to be one of those, pi over 6, pi over 4, or pi over 3.